The Central Development Laboratory at the National Radio Astronomy Observatory is responsible for developing cutting-edge technology for radio telescopes. One of the most important technologies that we develop at CDL is low-noise amplifiers. Radio science tells us that the best way to capture the extremely weak signals from stellar objects is to amplify them as soon as possible in a telescope with adding as little noise as possible. And in this video, our engineering team talks about the current and future low-noise amplifier technology being developed at the laboratory. And we hear a little from astronomers about the importance of this technology.
My name is Claudio Jarufe, and I am a research engineer at the Central Development Laboratory. Low-noise amplifiers are very important for radio astronomy receivers because they often set the limit of the noise performance. The signals we want to detect from the skies are very faint, have a very small amplitude, so we need amplifiers to detect these signals. We need a special type of amplifiers that are called low-noise amplifiers to make sure that we add the minimum amount of noise to the signal that we're trying to detect.
So the low noise amplifiers that folks here at CDL have been working on are really going to help with the noise in the system, and the lower the noise in the system is, the more sensitive our instruments become. And that's really important because when we look at things like protoplanetary disks or like, you know, the famous image of HL Tau, the sensitivity in those images is really what lets us see the gaps between the rings, or separate the rings from each other, where we can really see those planets that are forming in those gaps.
Mitch is working now on amplifiers for ALMA Band 6 receivers, and you can see him working under the microscope because all these components are very, very small. This is the place where we use this bonding machine to interconnect all the capacitors and transistors inside the amplifiers.
The NGVLA, or Next Generation Very Large Array, is a replacement of the Very Large Array and via Very Long Baseline Array telescopes. This will be the next U.S. flagship radio telescope. In our design efforts, we work very closely with the Central Development Lab, the CDL, for their engineering expertise to improve the performance of the telescope.
TKIPS stands for Traveling Wave Kinetic Inductance Parametric Amplifier. In contrast with semiconductor amplifiers, it uses superconducting materials. Being superconductors means that they can produce less noise than the semiconductor-based amplifiers. So one of the instruments that we have to test parametric amplifiers is a Blue Force cryostat. It allows to reach us temperatures close to 10 millikelvin. We need those temperatures because we want to isolate any other spurious effect on the amplifier. However, we would like to study the material as the temperature goes up, and we are interested in studying these parametric amplifiers at temperatures more reasonable, like 4 Kelvin. Commercial simulation tools won't give us the full information that we need to design parametric amplifiers. That is the reason for which we have developed our own software. Together with a co-op student, we have developed this tool. Here you can introduce all the geometrical properties of the parametric amplifiers, and the software will give us information like the propagation constant, the impedance of the parametric amplifier, or what is more important, its gain.
We are also working in another type of amplifiers called monolithic microwave integrated circuits. In this kind of amplifiers, you can have all the components of the amplifier integrated in just a single circuit. Here we have one example of an amplifier. Here we are looking at the layout. The total size of this amplifier is 2 millimeter by 1 millimeter. And on this software we can simulate the complete amplifier and also do electromagnetic simulations to make sure that everything is working fine.
In 5 years, we will be producing the best amplifiers existing in the world.